Welcome. We are going to see about the overview of classifiers. So Bayesian classification, the equation is if q0 of x is greater than q1, it belongs to class 0, and if q1 is greater, it belongs to class 1. Pi is the probability called prior probability, the previous occurrence probability. Qi is the posterior probability. So there are two types of errors. Class 0 misclassified as class 1 is false positive and it is called type 1 error. Class 1 misclassified as class 0 is false negative and it is a type 2 error. The limitations of Bayes' theorem is we need to know the prior probability in advance. This can be computationally or may not always be feasible, and we go for nearest neighbor classifier. So here we know that the correct class label for each prototype is identified based on learning. When we have a set of patterns, we need to identify when a new feature is given, that new feature distance is measured from all other points. So the point which is closest the class, which is the class, if many points in that k value has that particular class, that k value is assumed. K is an odd number, it may be 3, 5, 7, etc. So the distance between the feature vectors are identified, and for example here if k is equal to 3, we need to identify the number of features belonging to k is equal to 3. If it belongs to a star, then our new feature belongs to a star class. If not, it belongs to a circle class. So the k value is defined by us. We have discriminant function h of x is equal to 1 if g of x is greater than 0 and 0 otherwise. If g of x is q1 of x minus q0 of x, then it is Bayesian classifier. And linear discriminant function based on the classifier is if sigma, it's about neural network, if sigma wixi is plus w0 is greater than 0, then it belongs to class 1 and 0 otherwise. So neural network is a classification. Decision tree, we divide the data into classes based on a tree kind of structure. SVM, map the nonlinear data into higher dimensional space and try a linear discriminant function. Example is support vector machine. Thank you.